In this module, we'll generalize the earlier calculations to a multi-period lattice. Again, we'll only look at non-dividend stock, and then we'll generalize that further in the following module. So if we're dealing with many binomial periods, it's unrealistic to continue to have h equal to 1 year. What we'd like to do is to increase the number of binomial periods by decreasing h. In other words, if we have a 3-month option, be able to take h equal to 1 month and do that option in 3 steps, or perhaps even let h equal 1 day and use 90 steps to a 3-month option. So we're going to do an example here where we have a 1-year call and an h of 1/3. So we'll develop a lattice where we do 3 steps to the 1-year exercise. So here, let's recall how these up and down states are calculated. They will be different than the up and down states we saw earlier because h is no longer equal to 1. So for example, u is equal to e to the RH, so r was 0.08 and h is 1/3. And then we have plus sigma, and we now need a square root of h, square root of 1/3. Similarly, d is equal to e to the 0.08 over 3 minus sigma square root of 1/3. So consequently, you can see that the up and down stock prices 1/3 of a year are much more narrowly distributed than they were in the prior. You'll also see in this lattice that the expiration values of the option at time 1 year are again obvious. It's a strike 40 call, so when the price of the stock is 74, it's obvious that the exercise is 34 and so forth. So each of these exercise values are obvious. You'll also notice that throughout the lattice that the deltas are changing, as are the B positions. This is reflective of the constant rebalancing of our portfolio. Notice, too, that the delta is 0 in this state, and that's because the option is completely out of the money in the next period. In the next period, the option's worth 0, and so I don't need any stock and I don't need any T-bills, and the position is 0 there. But if you look at this state, I have a delta of 1. And the reason I have a delta of 1 is that in the 2 states that flow from there, I will have exercise with certainty, and that means that I need to be holding that stock at that moment, and I'm holding a T-bill position against it. Here are the formulas in more detail for SU and SD, just using the adjusted values of H. And if we do the backward substitution as we did in the prior module, we will ultimately get an option price of $7.07. To do it that way would require, we can see how many calculations, namely that we would calculate 1, 2, 3, 4, 5, 6. You can see that it would require 6 backward substitution calculations in order for us to ultimately get the price of $7.07. Using backward substitution, we could similarly calculate in these 6 steps the replicating portfolio in each of those 6 steps.